Welcome to tonight's video on section P-6, rational expressions. Rational expressions is the quotient of two polynomials. For example, x plus 3 over x squared plus 9. That's a rational expression. X squared plus 2x minus 3 over x minus 1. Those are rational expressions. Excluding numbers from the domain. Remember, the domain by definition means what x can be, like what numbers you can put in for x. That's what it means for the domain. So when you're asked to find all the numbers that must be excluded from the domain in each rational expression, remember one thing. In a rational expression, the denominator cannot equal what number? And if you guessed 0, you are correct. So basically, to find numbers that are excluded from the domain, you need to set the denominator equal to 0. So for example, for this one here, A, you just go x plus 5 equals 0, x equals negative 5. That means if I put negative 5 in for x, it would make the bottom of the fraction equal to 0. Therefore, that is the number that would be excluded from the domain. For the next one, if I do x squared minus 36 equals 0, then I go x squared equals 36, and when I take the square root, remember it's plus or minus. So there's two answers. X can not equal positive 6 and x won't equal negative 6. Both those terms, if I put them in to the denominator, would make it equal to 0. Simplifying a rational expression. The first thing you want to do is factor the numerator and the denominator completely. So for example, on the top, notice they have an x squared in common. And when you take out the x squared, you're left with x plus 3. The bottom, you can't factor the x plus 3, so you leave it. So then, it says to divide both the numerator and denominator by any common factor. So notice, there is a common factor that you can cancel out, and that is the x plus 3. So you're left with x squared. The last thing it says to do is to make sure and list the restrictions on the domain of the denominator, meaning what number can you not put into the denominator here? And if you said negative 3, you are correct, and so your answer would be x squared, and then you'd put a comma and say x could not equal negative 3, because that would make the denominator equal to 0. To simplify. So here's an example. So first, remember, you want to factor the top. So go ahead and factor the top. And if you said x plus 1 and x minus 1, you're correct. And if you factor the bottom, the factors of 1 that add to 2 are 1 and 1. So notice they share x plus 1, so you cross that out. So your final answer is x minus 1 and x plus 1. Now looking back here, what number can I not put into the for x? If I put it into the for x, it would make the denominator equal to 0. And you guessed it, it is negative 1. So you cannot have x equal negative 1. Multiplying rational expressions. Same concept. Factor all numerators and denominators. So basically here, if you look at the denominator on the bottom here, it's x plus 3 over x squared minus 4 factors to x minus 2, x plus 2. On the top there, it factors to x minus 3 and x plus 2. And the bottom denominator is x plus 3 times x plus 3. So then you can cancel out what they have in common. And remember, you can cancel up and down or side to side. so I can cancel, diagonally. So I crossed out here diagonally, x plus 3's, diagonally here, x plus 2, and that's it. There's nothing I can do up and down. So I'm basically going to leave the common factors, or the remaining factors there. I just multiply across, so the top is x minus 3, and the bottom is x minus 2 times x plus 3. I do not have to FOIL it out. The only thing that I want to do left is to say what numbers would make the denominator equal to 0. Well, notice if the number here that would make the denominator equal to 0 is 2. The number here that would make the denominator equal to 0 is negative 2. The number here would be negative 3. Those are the numbers that you could not put into x that would make the denominator equal to 0. Therefore, you have to list the restrictions as part of your final answer. Dividing rational expressions. Same process. So let's factor first. So when we factor the top, we get x minus 1 times x minus 1. When we factor the bottom, take out an x, and you're left with x squared plus 1. The only thing that changes is when it's division, you make it multiplication, and you flip the bottom and the top of the right-hand side. So notice here, when we factored it, take out a 3, and it's x squared plus 1. And when we factor x squared plus x minus 2, we get x plus 2 and x minus 1. So then you can cross out, and you get x minus 1 that you cross out there. You can cross out the x squared plus 1, and you're left with 3 times x minus 1 over x times x plus 2. The last thing you need to do is list the restrictions, what x cannot equal. Well, if you look here, x cannot equal 0, because that would make that equal 0. X squared plus 1, there isn't a number that you can put in that would make x squared plus 1 equal 0. Here, negative 2. And here would be positive 1. And those are your final answers. So it's not based upon your end answer, the restrictions. It's based upon what you started with. What would make the denominator equal to 0? Adding and subtracting rational expressions. With the same denominator, you basically just subtract the numerators. Remember something, when you subtract, it's like that's in parentheses. When you subtract, you have to add the opposite. So you basically distribute the negative sign into the right-hand side. So it becomes 5x plus 1 minus 4x plus 2. That is the numerator. The denominator is common, so it's x squared minus 9. I'd combine like terms, so 5x minus 4x is x, 1 plus 2 is 3, over x squared minus 9. Now, the only thing left to do is factor the denominator, which is x plus 3 and x minus 3, over x plus 3. And notice the x plus 3 cancels out. Whenever you cancel out everything on the top, you want to put a 1. So it's 1 over x minus 3. And then the restrictions. Well, the restrictions on the denominator are that x cannot equal negative 3, because that would make that equal 0. And it can't equal 3. So you can go ahead and do that one, next one on your own. You can pause it if you want to do it, and it'll tell you that the answer is -2 and x cannot equal -1. That would be your final answer. Whenever they have different denominators, basically you find the least common denominator by factoring. So in this case, notice you don't need to factor the bottom, so basically the common denominator would be multiplying the two factors. So the common denominator would be 2x minus 3 and x minus 3. And so basically, to get the common denominator, you take top and bottom and multiply by what they don't have. So notice on the left, you'd multiply by x minus 3. And on the right, you multiply by 2x minus 3. And that would give you the common denominator. Now, you FOIL. So x minus 3 times x plus 2 would give you x squared minus x minus 6. And on the right-hand side here, you can distribute the negative sign with the 4. You'd get minus 8x and plus 12. Then when you combine like terms, you get x squared minus 9x plus 6 over x minus 3 and 2x minus 3. And then notice that you can't factor the top, so you wouldn't be able to simplify it. The restrictions are x cannot equal 3, and 3 halves would make 2x minus 3 equal to 0. I'm not going to do the next one, the 3 over x plus 1. 3 over x plus 1 and 5 over x minus 1. We'll skip ahead to finding the least common denominator, how you would do it if there was not a common denominator. And here are the steps. Basically, you factor each denominator completely. So for example, here, notice the common denominator, or here you could factor a 5 and an x, so you get x plus 3. And here it would be x plus 3 times x plus 3 when you factor the denominator. Then it says list the factors of the first denominator and add to the list in step 2 any of the factors of the second denominator that do not appear on the list. So notice the first, if I was finding the least common denominator, the factors of the first denominator are 5x and x plus 3. Notice in the second denominator there's an extra x plus 3, so I'll add that. And that would be my least common denominator. From the product of the factors from the list in step 3, that is the lowest common denominator. So let's try it again here in a real problem. So here if I factor, I have x plus 2 and x minus 1. And then here I have x minus 1 and x plus 1. Getting the lowest common denominator, well in the first one it's x plus 2 and x minus 1. Notice I have an x minus 1 there, so the only thing I need to add to the list is an x plus 1 to get my common denominator. Now to do this here, to finish the problem, I basically need to multiply by what they don't have. So in this case, in the left, x plus 2 and x minus 1, what it's missing is an x plus 1. So I'll multiply that top and bottom. And then on this side, notice it's missing an x plus 2, so I'll multiply that top and bottom. And then I FOIL, so I get x squared plus 4x plus 3. And then here I distribute, so I get 2x plus 4. And then I leave my common denominator. And then I combine like terms. Now, if I could factor the top, I would, but I can't. There are no factors of 7 that add to 6. So I leave it. The only thing I have to say is that the restrictions are 1, because that would make this equal 0, -2, and -1, because those are the numbers that would make the bottom equal to 0. And the process would be the same if you're subtracting. And we'll go over those in more detail tomorrow. Hope you enjoyed the video. See you in class tomorrow.